All right, folks, here we are. My first attempt at making a video on the iPad with annotating notes at the same time. So let's see how this goes. So in this video, I want to focus simply on finding critical points. Remember that a critical point is a set of coordinates x, y, where both the derivative with respect to x and the derivative with respect to y are equal to 0. So at the point AB, the derivative with respect to x and the derivative with respect to y have to be simultaneously equal to 0. Okay? Just as in with functions of one variable, we know that critical points are just candidates. They're only candidates for a local extremum to occur. If we know that we have a local max or a min, then we also know that that point is a critical point. But if we start with a critical point, we don't know necessarily that we have a local max or a local min. But we'll worry about those details later. Let's first focus on finding critical points. I have two examples for you. I have a really straightforward one, and then I have one that requires a little bit more calculation, and then I have a third one for you to try on your own. All right, so here is the first example. I have a function of two variables. F is equal to x squared minus 6x plus y squared plus 8y. First thing we do is find our two partial derivatives. So let's find the partial derivative with respect to x first. So we take the derivative with respect to x of each of the terms. So the derivative of x squared is 2x. The derivative of minus 6x is minus 6. And then as far as x is concerned, y is just a constant. So the derivative of y squared plus 8y with respect to x is 0. And we need this derivative to be equal to 0. So we set 2x minus 6 equal to 0. That is equivalent to 2x is equal to 6, which then, of course, is equivalent to x is equal to 3. We also need the derivative with respect to y to be equal to 0. So first of all, let's find that derivative. The derivative of x squared minus 6x is equal to 0. As far as y is concerned, x squared minus 6x is just a constant. Then we get to y squared. Its derivative is 2y, and the derivative of 8y is 8. We set this equal to 0 as well, so 2y plus 8 is equal to 0. That's equivalent to saying that 2y is equal to minus 8, or y is equal to minus 4. So in this particular case, actually, the derivative with respect to x does not involve y at all. So for any y, as long as x is equal to 3, the derivative with respect to x is equal to 3. That's really important. This is true for any value of y. For any value of y. Similarly, the derivative with respect to y does not depend on x. So as long as y is equal to minus 4, we're good. So this is true for any value of x. Okay, but we do need both derivatives to be equal to 0 simultaneously. So for f of x equal to 0 and f sub y, the derivative with respect to y, to be equal to 0 simultaneously. So simultaneously, I'm going to emphasize that. It becomes really important in the next example. We need x to be equal to 3. Whoops. I'm going to write that as coordinates x, y to be equal to 3 and minus 4. Okay, so the x coordinate is 3 and the y coordinate is minus 4. So there's only one critical point. There's only one critical point. Namely, xy is equal to 3 minus 4. All right, so that was a pretty straightforward example, and that's mostly because the first derivative with respect to x and the first derivative with respect to y don't really interact. They are independently, you can independently set them equal to 0 and solve. All right, so let's go to the second example because this is a little bit different. So here I've got my f of xy is equal to 3xy minus x cubed minus y cubed. We start off by taking the two partial derivatives. So the partial derivative with respect to x is equal to, the first term I'm differentiating with respect to x, I'm left with 3y minus the derivative of the second term, so that's 3x squared. As far as x is concerned, y cubed is a constant, and so the derivative gives 0. I'm not going to be writing that one down. Let's also find the partial derivative with respect to y. From the first term, I am left with a 3x. The derivative of x cubed with respect to y is 0. And then for the third term, the derivative is 3y squared. I need to set both of them equal to 0. So set both equal to 0. So I need 3y minus 3x squared to be equal to 0. And I need 3x minus 3y squared to be equal to 0. The first equation, let me actually just call this one 1, and let's call this one 2. So for the first equation, of course, we can divide by 3. And I'm going to rewrite this as y equals x squared. And let's just leave the second equation as, or maybe let's divide it by 3. So I have x minus y squared is equal to 0. Now I'm going to, these two equations need to be satisfied simultaneously. So what I'm going to do is I'm going to substitute y equals x squared into 2. So I'm going to substitute 1 into 2. And then that second equation reads x minus, now y is x squared, all squared, is equal to 0. So that's equivalent to x minus x to the fourth is equal to 0. And I'm going to factor out an x. So x times 1 minus x cubed is equal to 0. Now that has two solutions. Either x is equal to 0 or 1 minus x cubed is equal to 0, and that latter 1 minus x cubed is equal to 0 is equivalent to x cubed is equal to 1, which is only has one solution, x equal to 1. All right? So now really I have two cases. So case 1, when x is equal to 0, what does that mean? Well, let's put it back into the first equation. In 1, this means that y is equal to 0 squared, which is equal to 0. So simultaneously, equations 1 and 2 are satisfied as long as x and y are both equal to 0. And so that's a critical point. All right, and then I have a second case, case 2, where x is equal to 1. Let's substitute that back into 1 in the first equation. In the first equation, this means that y is equal to 1 squared, which is equal to 1. So the two equations are simultaneously satisfied if both x and y are equal to 1. And so that point is also a critical point. All right. So we found two critical points. Namely, xy is equal to 0, 0, or 1, 1. All right. So now why don't you practice this on your own? So I've given you a third example where the function is 2x squared minus xy plus y to the fourth. Your first step is to find the two partial derivative, the partial derivative with respect to x and the partial derivative with respect to y. And you set both of those derivatives equal to 0 simultaneously, and then you solve for the values of x and y that satisfy both of those equations simultaneously. So you should find 3 critical points. I've put them at the bottom of the page. And so work this one through. I'm very confident that you can find these 3 critical points. So it's really good practice for you. So think of this as your time to work together in class. So give this one a try. And if you have any troubles with this particular one, send me an email. We will soon have a forum set up where all of you can discuss these kinds of exercises together. But for the time being, that is not set up yet. And so at the time, just give this a try on your own and just let me know by email whether or not this works. Talk to you soon. Bye.